Let's wrap up with our last problem in related rates. And this one was a little bit of a curveball, but let's see what we can do with it. All right, so a spherical balloon is expanding at a rate of 60 pi cubic inches per second. How fast is the surface area of the balloon expanding when the radius of the balloon is 4 inches? That's a question, so it should end with a question mark. Oh well. All right, so what do we know? We know that dv dt is equal to 60 pi. Is that positive or negative? The balloon is expanding, so it should be positive 60 pi. And we want to know the change of the surface area over time. So we want to know what is dA dt when the radius is equal to 4. All right, and the trick of the question, or the thing about the question that might throw you at the beginning, is we don't necessarily know a relationship between the volume and the surface area of a sphere. But that's not a big deal, because remember, there are 3 things that it's changing. It's not just the volume and the surface area of the sphere that's changing as it's filling with whatever it's being filled with. It's also the radius. And so we've got relations. We can talk about the volume of a sphere is equal to 4/3 pi r cubed. And we can talk about how the area is equal to 4 pi r squared. And so what we can do is we can solve this problem in 2 steps. We can differentiate this and use what we know about dv dt to solve for dr dt. And then we can use dr dt in this equation to calculate dA dt. All right, let's see how that works. And if that was the hint you needed to get moving, pause the video and see if you can solve the problem now. All right, so differentiating this, we've got the dv dt is equal to 3 times 4/3, which is 4, times pi times r squared dr dt. So moving the variables around, we've got the dr dt, which I want to solve for, is equal to 1 over 4 pi r squared times dv dt. And I know that r is equal to 4. So 4 squared is 16. And 4 times 16 is 64. So that's 1 over 64 pi times dv dt, which is 60 pi. And so the pi's cancel each other out. And 60 over 64 can be simplified to 15 over 16. All right, so now we know what dr dt is equal to. So let's differentiate this with respect to time. A is equal to 4 pi r squared. And so differentiating this with respect to time, we've got the dA dt is equal to 2 times 4 pi is 8 pi times r times dr dt. And now we just substitute in all of the values we know. 8 pi times r, which is, again, that's equal to 4, times dr dt, which we calculated down here to be 15 over 16. All right, and so that's equal to 32 pi times 15 over 16. And 16 goes into 32 2 times. And so that's a total, dA dt is equal to 30 pi. And what's our units for this? We're talking about dA dt, the change in area over time. So area is measured in square units for our unit of measurement, which is inches. So it's 30 pi square inches per unit of time, which is seconds. All right, so that's an example of maybe a time when the relation between the rate that you know and the rate that you don't know, there's not a direct relationship between those two things, but there's an intermediate variable that also changes over the course of the problem, and you can use that as your stepping stone. All right, so take a look at all of these examples and then work your way through the homework problems. There are a lot of homework problems, which gives you a lot of opportunity to practice getting used to related rates.